Hello grade 7 students, welcome back to another video discussion. So for today's video, our topic is all about measures of variability. The measures of central tendency show the values at the center of the distribution as what we have discussed during our last video discussion. So such information is not adequate to describe the characteristics of a set of data. Thus, the measures of variability put meaning into the entire distribution. So the measures of variability, or sometimes called the measures of dispersion, describe how varied, clustered, or dispersed the observations are in a given set of data. So in this lesson, we will study the four measures of variability or the four measures of dispersion, namely the range, the mean or the average deviation, mean deviation or average deviation. Then we have the variance and the standard deviation. Lesson 1, the range. The range, which is denoted by letter R, capital letter R, is the simplest measure of dispersion. It is the difference between the highest and lowest observations in a given set of data. It describes only the arithmetical spread of the observations in the entire data. Now, for the formula for the range, we have range R is equal to the highest value, HV, minus the lowest value, LV. So, for example, determine the range from the given data set. So, we have set A composes of data 80, 81, 83, 84, 84, 85, 87, and 88. Now, we are going to apply the formula. Simply determine the highest value. So, the highest value in this data set is, it's 88 ang kinadak-an nga value. And the lowest value is 80. So, simply subtract 88 minus 80. The range is equal to 8. So, if an extreme value called an outlier is included in the data, then the range has the disadvantage of being influenced by an outlier. Okay, lesson 2, the mean deviation. The mean deviation, or denoted by MD, refers to the average of the absolute values of the differences of the observations from the mean. Note that all observations are included in determining the mean deviation. Hence, this is more reliable than the range. Okay, so we will start with the mean deviation for ungrouped data. So this is the formula for the mean deviation for ungrouped data. We have summation of the absolute value of the difference between the given data and the mean all over n. So x there is the value or the score of the distribution. Then x bar, of course, this is the mean of the distribution. And n is the number of observations. So we have here steps to follow. First is to arrange the values according to magnitude. Then solve for the mean, which is denoted by x bar. After that, we are going to find the deviations. Then its absolute value. And then we are going to find the sum of the absolute values in step 4 and divide the sum of the absolute values by n. So we are going to apply the formula. Okay, so for example, find the mean deviation of the following data. So we have here, so these are the elements in set B. We have 75, 77, 79, 84, 88, 90, and 95. Okay, so first, we are going to find the mean. So, simply add all these scores here or data from 75 to 95, that is equal to 672. Now, with regards to n, pila man kabuok ag data? So, there are 8. So, that is why 672 is divided by 8, which is equal to 84. So, this is now our mean. Moving on, so we are going to construct a table like this. So, the first column, ang nasa first column, kadong given nga scores. And then, after ana, atong i-add sa second column, ang second column mo ni siya, x minus x bar or the mean. Ang x is ang score. 75 minus 84, ang atong mean, which is equal to negative 9. Then 77 minus 84, that is equal to negative 7. 79 minus 84, that is negative 5, and so on. Then on the third column, simply get its absolute value. It's always the positive of the given integer. So negative 9, absolute value is 9. Negative 7, 7, negative 5, 5, 0, 0, 4, 4, 6, 6, and then 11. Then we are going to find its summation. I-add na to ni sila nga column. 9 plus 7 plus 5 plus 0 plus 0 plus 4 plus 6 plus 11. The answer here is 42. Then, that's the time we are going to apply the formula. So, kani nga part, summation of the absolute value, kani 42. Then, ang n is the number of observations. So, pila man ni siya kabok? 1, 2, 3, 4, 5, 6, 7, and 8. So, 42 divided by 8. So, the mean deviation rather for this data set is equal to 5.25. Now, let's proceed to mean deviation for group data. So, this time we have another formula. So, f is the frequency of each class interval. X sub m is the class mark of each class interval. The x bar is the mean of the distribution. And n is the number of observations. Now, another steps here. Solve for the value of the mean, determine the deviations, x sub n minus x bar, get the absolute values of these deviations, and then multiply each of these absolute values by its corresponding frequency, add the results in step 4, and divide the sum of the absolute values by n. Here, example. So this is an example for mean deviation for group data. Determine the mean deviation of the frequency distribution below. So, given ni siya nga table, the scores nga in group and then frequency. Okay. Then, we are going to construct a table like this. So, kanina may gihatag, we are going to add 2 columns to the right, consist of class mark and the product of the frequency and the class mark. Okay? Now, class mark. So, again, as na-discuss naman yung last time during our last topic, our last video. So, simply add the lower limit and the upper limit of the given class interval divided by 2. So, here we have 62, 67, 72, 77, 82, 87, 92, and 97. After that, on the last column, i-multiply as the frequency of the class mark. So, 2 times 62, 124. 5 times 67, that is equal to 335. Then 9 times 72 is 648. 10 times 77 is 770. 8 times 82 is equal to 656. 7 times 87 is equal to 609. 5 times 92 is equal to 460. And 4 times 97 is equal to 388. Then we are going to get its sum. Kani siyang mga answers. So we have 3,990. Okay. Now, we are going to solve for the value of the mean. Ano nga table? So our mean is the summation of f times xm. So we have 3,990 over n, which is equal to 50. Thus, the mean is equal to 79.8. So, dili pa ta mo end ana. Thus, we are going to have this table again. Okay? So, ang 3-column nga table ganiha sa atong first step sa pagkuha og mean magamit. So, ang ato rang wa ato is kadong fourth column. Thus, adding 3 columns again, we have x sub m minus x bar, its absolute value, and then the product of the frequency, and the answer nimo ani nga column. So, as you can notice, kani nga column, we have 62 minus 79.8. Isa ganin 79.8. This is our mean. Okay. So, is equal to negative 17.8. Then, ani nga column is ang absolute value, ang positive. Then, ani is ang frequency ug ang answer ani nga column. So, the answer here is 35.6, 64, 70.2, 28.0, 17.6, 50.4, 61.0, and 68.8. Now, we are going to get its sum. I-add na to ni siya. So, therefore, the sum here for this column is equal to 395.6. Okay? Then, for the mean deviation, we have 395.6. Kani siya, ang summation is divided by 50, the n. The answer is 7.912. Okay, so that's it. Now, for the last lesson, we have the variance and the standard deviation. So the variance denoted by s squared and the standard deviation s are the most commonly used measures of variation. The standard deviation describes the extent of diversity of the set of observations in the data. It is widely used to find how close or how far the observations are from the mean in the distribution. So if the data in the distribution is the entire population, we use the notation for standard deviation and variance as follows. So we have this notation for population standard deviation, this one for population variance. Now we use the following notation for a distribution involving a sample. We have S for standard deviation based on sample data, and S squared for variance based on sample data. Okay, here we have the formulas for variance and standard deviation for ungrouped data. Okay, now the variance, we have this formula. Ang standard deviation is simply the square root of the variance. Okay, di ba? Na-notice ninyo, maura siya formula. Ang difference ra, ang square diri sa variance, we simplify, extract square root both sides of the equation, making it to standard deviation formula. S is equal to the square root of the variance. Now, x here is the individual values in the distribution. The x bar is the mean of the distribution, and n is the sample size. Okay, steps to follow. Compute the value of the mean of the entire data. Get the difference between each observation and the mean of the data. Square the deviations from step 2. Determine the sum of the squared deviations in step 3. Divide the sum by n minus 1. The number obtained is the variance s squared. Then get the square root of the variance to obtain the value of the standard deviations. So these two are just related to each other. So in order to get the standard deviation, we are going to find the variance. In order to get the variance, we are going to square the standard deviation. So simple as that. Now, example. Determine the variance and standard deviation of the following set. So we have that given set. Okay, so we are going to construct a table like this. So the scores on the first column and then x minus x bar. So, mo ni siya ag mean. So, nakuha naman na nato last time. The mean here is 84. Okay. Okay, pakita na ko. So, summation of x, that is 672. Summation sa scores, yung pila ka box scores, that is 8, so 84. So, mo na siyang 84, agi subtract ani sa mga scores, kaya mo man siya ang mean. Now, on the third column, we are going to square kung unsay answer na to dire. So, negative 9 times negative 9, 81, then 49, 25, 0, 0, 16, 36, 121. Finding its sum, kaning mga answer, we have 328. So, for the variance, we have 328 is equal to 8 minus 1. Then 8 minus 1 is 7. 328 divided 7 is 46.8571. Now, for the standard deviation, we are going to get its square root or extract square root out from the variance. So, square root of 46.8571 is positive negative 6.85. Now, subtracting 6.85 from the mean and adding 6.85 to the mean, we get, so, 84 minus 6.85 na sa inyong module is equal to 77.15, and 84 plus 6.85, that is 90.85. So, therefore, the interval is from 77.15 minus 90.85. So, the standard deviation of positive negative 6.85 means that the scores in the sample data could have been drawn from a population of scores that are in interval 77.15 to 90.85. Now, moving forward with the mean and the variance and the standard deviation for group data. So, we have this formula for variance and formula for standard deviation. So, x sub m is the class mark, f is the frequency, and n is the sample size. Example. Compute for the variance and the standard deviation of the given set of data shown in the frequency distribution below. So, mo ni siya a given. Now, what we are going to do, we have to construct a table like this. So, pinasayunan inyo ra jud nang i-follow ang mga table nga gihatag para dali ra maansiran. Kay dili man ni siya pwede og shortcut. We have to do this step by step kay bawo mo ang sagikan mo na siya. Okay, for the class mark, we have 62, 67. Asa ganinigikan si class mark? Ang average sa lower limit and the upper limit of the class interval. In short, or gusto mong yes, in short, ang katunga nilang duha, 60 to 64. So, we have this columns for this. Then, ang fourth column is ang product sa frequency ug sa x sub m. So, 2 times 62 is 124. 5 times 67 is 335. 9 times 72 is 648. 10 times 77 is 770. 8 times 82 is 656. 7 times 87 is 609. 5 times 92 is 460. And 4 times 97 is that is not 124. That is 388. So, let me have some correction for this. Okay, so this is not 124. I'm so sorry. It's 388. Okay, I don't know how to write 8 here, so I'm so sorry for that error. Okay, now, getting its sum, the answer is 3,990. This is correct. Now, in here, kaning nga column is x sub m squared, or i-times ninyo ang class mark by itself. So, 62 times 62 is 3844. 67 times 67 is 4489. Then 72 times 72 is 5184. 77 times 77 is 5929. 82 times 82 is 6724. Oh, I'm so sorry. Okay. That's 24. Ako lang siyang i-check sa inyong module. 87 times 87 is 7569. 92 times 92 is 8464. And 97 times 97 is 9409. Then, on the last column, i-multiply your out frequency ug ang answer, dire. So, we have, this is 2 now. Okay. 2 times 3, 8. 4, 4 is 7,688. 5 times 4,489 is 22,445. 9 times 5,184 is 46,656. 10 times 5,929 is 59,290. 8 times 6,724 is 53,792. 7 times 7,569 is 52,983. 5 times 8,464 is 42,320. Then 4 times 9,409 is 37,636. Finding its sum, adding apart, is 322,810. This is correct. Now, this is our solution for the variance. We have n is 50. Open parenthesis, ang answer dire nato 322,810 minus kani 3,990 squared all over 50 times 50 minus 1. So, atong i-multiply ni silang duha. Kani, 50 times 322,810 is 1,600,000, that is 16,140,500. Then, ang 3,990 atong squared is 15,920,100 times by itself. Then 50 times 49 is 24,050. 16 million minus 15 million something is 220,400. Divided 1, the value of the variance is 89.9592. Then, simply extract the square root for the standard deviation. We have positive negative 9.48.